want to get into more specific topics. And I see possibly we had a bit of a delay on the live stream. Let me briefly ensure that everything's going all right technically. Maybe someone can give brief feedback if the stream is online. Okay, perfect. I think I will briefly repeat myself because it looked like we did not go live on time. So let me welcome you a second time. Never hurts. Welcome again to the Community Workshops number 2. Twice is the charm. It's also the second Community Workshops. And today we'll be having great sessions coming up from the community, by the community, for the community, about Wonderland Engine. Quickly, for everyone who doesn't know yet, Wonderland Engine is a development platform for VR, AR, and 3D on the web. That means you can build efficient WebXR applications in environments that you are used to from native development. If you want to get into Wonderland Engine, please join our WebXR, our Discord server, the Wonderland Engine Discord, on discord.wonderlandengine.com. And feel free to also subscribe on YouTube. We're putting a lot of effort into making entertaining but yet educational YouTube videos there for how to build WebXR content. Finally, if you want to get some in-depth tutorials on more niche topics, go to wonderlandengine.com/tutorials and find short written tutorials there. So let's see what we can expect today. We are bringing with us Nithin Steven, who is going to talk about synthesizing music. His topic is Sounds Fake, Synthesizing Music for VR Instruments. We have Daniel, also known as M2. Daniel Adams is going to talk about commanding speech, voice commands in WebXR. And last but not least, we have Elia Ducceschi. And he's going to be stating the obvious, why you should be using finite state machines. Before we get into the first session, the format is going to be roughly 10 minutes, short and sweet sessions, and then a Q&A with live, the speaker who is doing the session, 5 to 10 minutes, and then we'll be going into the next session. So feel free, while you listen to the session, just already ask your questions and drop them into the chat. We see them here, and we'll try to ask as many questions as we can during the live Q&A. So let's jump right in with Steven in synthesizing music for VR instruments. You will have known Steven already from the apps that he released. He built many things, starting with the AI classroom, where you can basically, over voice chat, ask an AI questions, and it will then talk back to you. Absolutely amazing use case. It works even on mobile, VR, and everything. A TV viewing room. Swipe Surfer is a game that runs even on mobile and desktop, so super cross-platform. Again, a very, very nice demonstration of WebXR and the cross-platformness of it. And Red Light, Green Light, which you might have played on Construct Arcade. So without further ado, let's get into Steven's session.
My name is Nithin Steven, and I'm currently working at Wonderland Engine as a solutions architect. I've been around in the community for past 2 years, and I have made a couple of experiences such as AI classroom and TV room, and I also made a couple of games such as Red Light, Green Light, Swipe Surface, and last but not least ROTN Rotten, which is a Halloween themed game that I made recently. So I really appreciate if you guys go and check it out. So apart from being a developer, I'm a musician as well. And I'm always keen to incorporating real life problems and real life stuff into my development journey. I really need to play and learn an instrument, but I don't have the luxury to buy them all. So I thought, why buy them if we can just make them? That's the power of VR or any immersive technologies. So that was my main motivation behind making this library. So at the end of this workshop, you will be able to play your favorite instrument in the air in front of your loved ones. So without any further ado, let's get straight into it. So the first thing that we want to do is to set up an NPM project on Wonderland Engine. You can find a tutorial on how to do that on Wonderland Engine's official website. You can click on Learn and click on Tutorials to access tutorials similar to this. So once you have the basic NPM project set up, you can click on any folder in the asset browser and right click and click on show in folder. And on the navbar, you can type cmd to access a prompt on the root directory. Let us come back to the Chrome. And this is the library that we're going to use today, Music Instrument.js. It's made by Rackanima. I'm not sure whether I'm pronouncing his name properly, but it's a nice library and it do have a vast amount of instrument supported. So let us install this library. So copy the npm install command and paste it on the command prompt. It will install the library. Perfect, up to date. So let us come back to the Wonderland editor and open the JavaScript folder and open up bundle.js. And let us also require the component here. Music instrument.js. Awesome. So by this, I guess we will be able to import the function from the library to any other components. So we have this button component with us, which is attached to this button object right here. So we are going to be modifying this component so that whenever we click this button, we will play an instrument and a specific tone of an instrument. So let us open the button.js. So this is the function that corresponds to when we are clicking the button. So let's go back to Chrome and copy paste the usage, how we can use the instrument to import music. So let's copy paste it under the button component and it's called main function. Let us remove these 3 lines because they are playing 2 instruments at the moment, grand piano and as well banjo. So let's only play 1 instrument for now. And let's also console log this so that we can get an idea of like how many instruments are there. Great. So let us call this main function on the on down. My bad. So main. So this will hopefully play a banjo sound whenever we are clicking on the button. So let us run this program and let us look it's doing the job or not. So if you press package and start server, which is a green button right here, it will open a new tab on Chrome, which will run the app. So let us click the button. Let's look whether it's playing the sound. Yes, it is playing the sound. Awesome. Now that we know how we can import a function from an NPM package into Wonderland Engine, let us fast forward to the project that I have made with it. So as you can see, I have imported a beautiful scenery here in the background. So it's a model from Sketchfab. You can download beautiful models such like this for free from there. And this model is made by Conrad Justin. A great shout out because this model have won some awards in the past, I guess. Anyway, it's a beautiful scenery to look at. So coming back to topic, we have the good old button, but we have duplicated them to have this much amount of button. Each button have a name which corresponds to the note they are supposed to play. So let us look at the button.js and let's look why it's changed. Here, so you can see it's a good old function, but we have changed the function's name to play instrument. And also we have added 2 additional conditions. Like if the note that we are playing is next or previous, we should load the next instrument from the library. So otherwise it will just play the note. So on hover, we are playing the instrument. That's it, nothing more, nothing less. So I have also added a additional component, which is stick.js, which will help us to play the instrument with a stick in VR. And Wonderland comes with inbuilt hand tracking capabilities, so we don't need to set it up. It also have a finger cursor component which will help us to play the button by default. Let us package the entire project and look at our final result. So we are in the Chrome browser now. As you can hear, there's a soothing background sound which is playing, which consists of birds chirping, bells ringing, etc. This is because I have configured a Howler audio component to the player object like this. So one thing that I like most about WebXR or Wonderland Engine in specific is its cross-platform capability. It just works out of the box for all devices out there, like PC, mobile, virtual reality headsets, augmented reality headsets, etc. So let us try to play this instrument here. Awesome. So let's try to load another instrument by hovering over next. Let's play the piano. Awesome. There's a guitar. We do have a wide variety of instrument list. I guess it's around 200. I'm not sure. It also has sax. Awesome. So whenever you're done with your music playing, you can applaud yourself. Awesome. As you can see, it also supports hand tracking, and you can change the instrument that you're currently playing by clicking on the next. And you need to give it a little bit of time because it takes a little bit of time to load the instrument. So you can play it by touching each keys like this. This one right here is a game changer. With mixed reality, you will be able to play instrument as well as see the audience at the same time. Using an AUX cable, you can connect your headset to a portable speaker. That way, your audience can also hear you. The applications here are limitless. You can connect it with an actual physical instrument with Web MIDI API. With proper implementation, you can even use it for live performance. The whole project is open source, by the way. You can find the links in the description. Thanks for watching.
Awesome. And of course, we have Steven here live with us. We are now entering the Q&A session. So please, everyone, ask your questions. And here we go, Steven. Welcome to the stream. Great to have you here. First of all, thank you so much for putting that effort into this session. I think there's so much amazing potential that people can now take and just run and build their own instruments. How did you come up with this idea? I mean, you basically said during the session, right? But how did you then find how to do this?
To be honest, like I'm always keen to do music kind of stuff in virtual reality and augmented reality extra. So I actually came across this component by searching, I guess. It was at the project day, I guess. Like, of course, in our company, we had a project day. So that's when I just thought, like, why not just search it up, like, search for a component which does have an instrument with it. Then I searched it and I got it, and here I am.
Yeah, so for people who don't know, the project day is basically an internal event that we do once a month where everyone in the company, independent of whether they're a programmer or not, sits down and works on a project. Right, just for context for people how that worked out. Awesome. So we do have questions in the chat already. So let's start with this one. Kiploy asks, I see you have Copilot, I guess, GitHub Copilot in your VS Code. How well does that work with WLE components?
Well, that's a good question, and it depends actually. So, if you're starting a new project from scratch, Copilot really can't help you that much. But because, like, I don't know Wonderland Engine's API references, but if we code more, the Copilot will save our data from the previous components. So it can suggest us like which it can suggest us new codes which contains Wonderland Engine's API references that we used previously, so that we can reuse it. I actually found it very useful in many instances. So basically, generally it's a powerful AI component tool for programming language.
Nice. So it learns with you.
Yep.
Perfect. Okay, next question is La Majestic asking, sounds fun to play. Any particular reason you chose to hover instead of clicking on the buttons?
No specific reason at all. You can use it either on down or on hover. It's depend. It's like you can use wherever you want. I can argue that hovering is easier for clicking, but actually it's up to developers here.
Okay, perfect. There we go. Next question. Really cool indeed. Do you hide the entire environment on AR, or is that a separate app? So I guess it's referring to the pass-through app. Sorry.
Got it. So there's a component that I actually made. It hasn't been made to the repo yet. It's called AR mode active switch. And there's an inbuilt component which is already there, which is called VR mode active switch. So I modified it so that it adds an event listener to AR button. And I added the component to the environment. So that way it knows when we're entering the AR and it will hide all the object.
Perfect. That's cool. We should open source that component.
Yep.
All right. Florian, who did a session last time, he asks, how difficult is adding MIDI into a Wonderland Engine project?
It's very easy. So there's something called Web MIDI API. You can integrate very easily. It's just an NPM project. You can add it just like I did the music instrument JS. And the interesting thing is you can connect keyboard or any MIDI instrument to your Oculus Quest using the USB-C cable. I guess this is the one. So you can just plug it in and it just works. So it's basically a Web MIDI API, and as you know, like Wonderland Engine comes with NPM, so it covers all the capabilities of the web. So we can use Web MIDI API to play real-time instruments.
That would be so cool for like live concerts or something. Someone with like VR-assisted music making in front and then just producing a song live. Sounds really cool. All right. One more question here by Sandeep K. How much lag can we expect in loading time for awaits? Maybe we need context for that question, but is that loading time of the app maybe? Let's start with loading time of the app and awaits. We can.
I guess I understand what I can understand what he's referring to. It's he's kind of referring to the time that we need to wait for the music instrument library to load.
Okay, yeah.
This is something that I mentioned in the community video. So actually, it does take a little bit of time. So one thing that we can do is we can preload whatever instrument that we want beforehand, so that we don't have to have the wait time. So the problem is that we don't have we don't have luxury to choose from which instrument that we want. Or we can just load everything, but it's unrealistic to load all the instrument, because I guess it's all around 900 MB or something, the entire music instrument library. So
yeah, I remember
just load what we want.
hundreds.
Yeah. So I think like for each instrument, it's around 1 MB or something. So it would be fairly easy to preload 5 instruments at a time if you want. So it's actually a developer's choice to whether load them dynamically or preload them.
Perfect. Awesome. Very cool. That was our last question. So again, thank you so much, Stephen. And thank you also for all the work you've been doing in the community and all the apps that you've been building. Thank you so much from the deepest of my heart. And with that, we will return to the next session. And thanks for coming on.
Thank you so much. Pleasure is mine.
All right. We continue with Voice Commands in WebXR by Daniel Adams. Give me 1 second. There is a banner left here. Here we go. Excuse that. All right. Voice Commands in WebXR by Daniel Adams. Daniel is probably best known for having created the WebXR Discord and is now maintaining that as the admin, but he's also working at Zesty Market, both on the ads at the rentable spaces in WebXR that Zesty provides, but also on Robot Rally, a multiplayer shooter with Wonderland Engine. Today, Daniel is here to talk about speech commands in WebXR. So with no further ado, let's get into the session. Pardon. Which one is it?
Hello, my name is Daniel Adams, also known as MSub2, and today I'll be presenting a project that utilizes voice commands to enable user interaction within the world. Voice interactions have a wide array of applications, whether it be to better support devices with limited methods of interaction like Google Cardboard, or for purposes of immersion, but I find that it's still very rare to see it utilized in WebXR projects. This is likely due to the fact that most automatic speech recognition services that people are aware of today are all paid services. Think offerings from Amazon or Google, etc. However, I've been working on a polyfill for speech recognition, which is a part of the Web Speech API and allows for voice recognition and speech synthesis, that utilizes a free and open source speech-to-text server from the Sepia framework. Now, I hope to release this polyfill very soon. I have a couple things left to do on it, but that is what we'll be using in this project today. So let's start by taking a look at the editor. There's not much in here that's been added from the default VR starter project. You can see here we have a text component in the world. This is what I'll be using to display the transcript. We have a speech component here, which you can see just holds a reference to that transcript display. The rest of the logic is internal. We'll take a look at that in a second. And then we have our cube. This is what we'll be acting on today. So you can see it has two components, a speech target component and a cube test component. The speech target component is what lets it be acted on by our voice commands. You see that it has a name, cube. It has a reference to our speech object. It has a target script, which is cube test, and functions, spin or stop. Essentially how the system I've made works is you speak out a voice command, and then that command is parsed for two things. It looks for a subject. So our subject can be any speech target. When the speech target is first instantiated, it registers itself with the speech object. So the speech object always knows what in the scene can be acted on. If it finds a speech target within your command, then it looks for an action to perform on it. And so you can see here we have two functions, spin and stop. These would be actions that would be performed on the cube from our voice command. So let's take a look at the code to get a better idea of how this works. So right here is our speech component. You can see we import Sepia speech recognition init from my polyfill. And then we do some setup here. This is a list of speech targets. When they create themselves, they register themselves by just pushing a reference to them into this array. And here's where we actually initialize speech recognition. So you can see here, we start by essentially detecting whether we're in Chrome or not, because Chrome supports speech recognition natively. It's one of the only browsers to do so, and it uses the WebKit prefix. If this is not defined, if we're in a browser like Firefox, then we call sepia speech recognition init, and this returns my polyfill's speech recognition class. Once we have one of these, we set the Windows speech recognition object to be whatever we found, and then we create a new speech recognition. Now you can see here I do some additional setup based on whether we're in Chrome or the polyfill. This code is a little outdated. This could actually apply to both of them. And we have a couple of event listeners here. When the spacebar goes down, that starts the speech recognition. When it goes up, that stops it. And then we have an event handler that whenever we get a result, it takes the transcript from the result, displays it on our transcript display, and then parses it for subjects and actions. So you can see this parse function here. To do this, we take our transcript that we got, and then we split it by space to get a list of tokens. We look for our subject first, looking through our list of registered speech targets, and seeing if any of their names matches one of the tokens from the transcript. If it does, then we have our target, and we can continue, and then we look for an action, which, if you recall, is one of the specified functions on the speech target component. If we find both of them, then we call that action on the subject. So if we look at speech target here, it holds a list of possible functions, which is taken just from comma splitting the functions list on the parameters. And then we take a reference here, we push ourselves to the speech targets list on the speech object, and then we take a reference to our target script. So if you recall on this, it was cube test. So we call get component cube test to have a reference to that. And then this is that call function here. So if the voice command had a valid function, then this calls that function dynamically through that. And the cube test function is very simple. It just spins a cube and it stops a cube. You can see here there's basically no code. It's the simplest thing I could think of. So let's go ahead and take a look in Chrome for a demo. So here's Chrome. If you recall, Chrome natively supports web speech. So this will be just utilizing the built-in speech recognition for Google Chrome. So we'll spin the cube, and the cube spins. And then to stop the cube, stop the cube, and the cube stops. So you see it finds the speech target, cube, and then performs the action spin or stop on it. So like I mentioned, Chrome supports this natively. Let's take a look at Firefox, which actually utilizes the polyfill. All right. So now we are in Firefox, and we'll do the same thing. Spin the cube. I might need to reset my mic permissions here. Firefox can be a bit finicky if you have multiple audio devices. So we'll trigger that. All right, this should work. Spin the cube, and the cube spins. Stop the cube. And just to remind you, Firefox does not natively support speech recognition. This is using the polyfill that I have wrote that utilizes a sepia speech-to-text server, which is currently running locally on my machine. So yeah, that's a quick demo of using speech recognition to interact within a virtual world, on desktop at least. I'll cut now to a quick demonstration of this same thing, but in VR. And now to demo our XR speech interactions on the Quest 2 in WebXR. Now, keep in mind, Meta Browser, despite being based on Chromium, does not actually support speech recognition natively. So this is only the polyfill running right now. Spin the cube. Stop the cube. And there you go. So this polyfill works cross-platform, works on desktop, works on Quest 2. I think this will be a great resource for people that want to easily enable speech interactions within their own apps, as long as they're able to run the accompanying CPS speech-to-text server, which you're able to just pull from a Docker container and run locally. It's part of a larger framework called the CPF framework, which is meant to enable Home Assistant type stuff. It's really cool stuff. I'm very grateful to the original author for writing so much of the code that the polyfill uses here. Yeah, so I'll see if I can provide some links to that, and thanks for watching.
Awesome. And of course, we have Daniel here for us in the Q&A. Here we go. Daniel, welcome to the stream.
Yo.
Thanks for this awesome session. I think voice commands are a particularly interesting and important step for WebXR. And I'd be very interested in what kind of made you tackle this problem.
Yeah, so I actually initially worked on this a long time ago, maybe like a year ago, on like a completely separate project where I thought, hey, it'd be cool if I could put voice stuff in here. And so that was originally done with Speechly, which is a third-party sort of speech recognition platform. They're very good, but I came back to the project for this workshop to demonstrate, and I found that, oh no, it doesn't work anymore. So I ended up rolling my own solution.
It's amazing also the way you approached it. And to that, with the polyfill, there's one question by Florian, who is asking, is this going to be open sourced?
Yes, absolutely. I have, like I mentioned in the video, there's a couple things that I still need to do on it. As it turns out, when I was preparing to record for this, I realized that I thought I had bundled everything into one file successfully, but I did not. There is a single audio worklet file that is not inlined and doesn't seem to want to inline properly, so I need to take some more time and figure out how to get that working. So for the demo you saw, I actually just had to put that file in separately so the whole thing would work. But yeah, once that's done, I'll definitely open source the Wonderland project, open source the polyfill. I want people to be able to use this, and I think like being able to utilize open source speech recognition stuff is like so powerful.
Awesome. I think there's one very technical question here, which is why aren't you putting the window.chrome speech inside the init function?
Let me. So the code was mostly based off of what I had written like a year ago, so I hadn't used Wonderland quite as much. I might have just put it in start just because, probably, but I think it would work in it as well.
Wonderful. Then we have one more question related to voice, which is, are there any additional monetary costs in using the polyfill API?
No, because it's using I'm using the CPA SGT server, which, like I mentioned, is running locally. You can self-host this anywhere. So you could just put this on your own server. The other thing that I still need to work on is actual configuration when you initialize the polyfill so that you can interface with the server correctly, because there's a couple things like built-in authentication and other things like that the server provides that I need to let you tap into. But yeah, it's totally self-hostable, no monetary costs beyond what it takes to run the server.
Awesome. Then we have one final question by La Majestic, unrelated to speech, but how are you doing multiplayer in Robot Rally? I am super interested. Probably played more Robot Rally before, I assume.
Yeah. I can't get too in depth, just because sort of like IP reasons and whatnot. But I will say that we are using Wonderland Engine is our like client for everything, and we are using Calisius to handle the sort of all the game logic, all the server logic, hit validation, things like that. And our voice server is using a Media Soup SFU, which took a very long time to set up.
Very awesome. Yeah, but I played Robot Rally myself. We actually play it with the Wonderland team regularly, just to like see the progress, and absolutely amazing, super fun. All right, with that, thank you so much for taking the time, Daniel, and thanks for the awesome session. I hope that a lot of people will take it and build cool things. I already saw that you might be able to do spells and these kinds of things with with voice commands, which would be really, really cool. Thanks also like for all the amazing work you're doing for the entire WebXR community, not just for Wonderland Engine, of course. With hosting the WebXR Discord, it just brings everyone together, and it like gives people a common space to exchange information, and especially in these early days, that's absolutely important, and like basically creates a huge big family. So thank you very, very much, and thanks again, and see you soon.
See ya.
Awesome. Very wonderful, which brings us to our final session. Here we go. Our final session is going to be Why You Should Use Finite State Machines by Elia Ducceschi. Finite state machines, just as a quick introduction, as it's not in the session, are basically what you might have learned in theoretical computer science in your university studies, but they help immensely when managing more complex, for example, character controllers, but generally AI and these kinds of things in game logic. So it is a slightly different approach to especially doing logic in a component, but it's absolutely worth it. You'll see it. It's super interesting. Elia, you will probably know just like by being on the Discord server. He's been in the community forever, and he's released a bunch of cool stuff since. You will know him from his recently featured on the MetaQuest browser game, Mr. Not, Enough is Enough, which is a full game with a storyline and everything. Highly recommended. It has a bit of a learning curve, but it's absolutely beautiful when you get through it. So stick to it, try it out, play it. Sketchy is basically a tool with which you can map out and sketch things with boxes and color them beautifully. Also free for you to see, and I believe possibly also open source. I'll ask him in a second. But yeah, that's not it. He did so many amazing developer tools, from frameworks for grabbing and throwing that Yinch in our last community workshops did a very great session on, that you can have a look at to see how it is set up, to like a tool that allows you to see the browser console inside VR, so you can debug directly without going through the Chrome inspect tools. A tool to just tweak variables, for example, for game development, and a full-on physics-based character controller. All of that you will find on his itch.io page. With no further ado, let's go into why you should use finite state machines.
This is me, Pipo, also known as Elia Ducceschi. I'm a Wonderland Engine developer and the creator of Mr. Not Enough is Enough. Today we are gonna talk about FSM, but since the presentation I made was way too long, I hope you already know what an FSM is, because we are going to fast forward directly to the tutorial. See you on the other side. Hi, this is me again. The aim of this tutorial is to create a character that can idle, walk, and jump. We will use the FSM included in the PP library I built for the Wonderland engine. We are also starting the project with a PPFO template project that already imports the library. Let's not waste more time. Okay, let's first create a character and add a mesh as a child. Mesh. We will use a cube. We need to create a material for this. Let's use red. Darker. Okay, let's add a floor. Need to create another material. Okay. We need to scale this floor and rotate it. And we also need to offset a bit the mesh so it's stay on the floor. Okay, as last we also need to change the camera position so that it let us see in third person. Now we need to create the script and we need to add to the project settings. Okay, and now we can add it here. It should be all. Let's see on Chrome. Okay, it's working, the script is updating, so we can now move to the code. Okay, let's remove this thing first and create our FSM like this. The first time it always does this. Let's also update this every frame. We now add our states. Let's start with work and idle. And work. And let's also create the transition for this. From idle to work. From idle to work, call it start work, and from work to idle with end. Let's initialize our FSM on the idle state. Okay, we now need to specify what this state will do every frame. So we have this idle update function. And we also add something similar in the work, and let's add them here. The update function will get the DT, so it's fine to leave it. And now what we want is that when the axis value is greater than 0, we want to start working. We are using some extension method from the PP library like this. And what we do is this, to perform the start work transition. Similarly, we can do this in the update to stop working. If this is 0, we go back to idle. For now, it's not doing anything, but we can use this to debug our FSM. And we can give it a name. Okay, let's see on Chrome. Okay, as you can see in the log, the FSM is working. There is just a small error here. We can now add the movement logic. We will use a direction converter. That's something that it's in the PP library. This will convert our 2D direction from the strict to a 3D one. Okay. and we can do it like this. We pass our axis and our conversion transform that will be the player transform. We also specify the up of our conversion. Let's define a speed based on the axis intensity and our movement, that will be the direction scaled by our speed multiplied per dt. Okay, and now we just need to translate the object. Okay, let's see if this works. Okay, there is a small error. I just needed a T here. Ooh, like this. Okay, it's working. Let's go back. We now want to add the jump. We can do it in a similar way. Jump update. Blah, blah, blah. We want to go from walk to jump with start jump, and on end we go back to walk. Let's do it like we are going into this state when the select button is pressed, so like this. On press end, and we go to the start jump. Let's remove this code here for now. In this case, we also need to add a transition function here to set up some variable. Let's call it start jumping, because we need to specify our jump speed. Let's do it like this. And we can use a value like 10. Okay. And what we want to do is to always translate by the movement direction, so we keep moving like that. So we need to save this. And we also want to define a jump movement. So we can do it like this with our jump speed multiplied for the dt, and we translate the object by this value. We also need to decrease the jump speed like a sort of gravity. let's do it like this, and that should work. We also need to stop jumping when the character is on the floor. We can do it like this. When the jump speed is negative, so I'm going downward, and the character is on the floor, we stop jumping. In this case, we stop jumping, but we also need a small adjustment to be sure the character stays on the floor. That is to move it back up, like this. Okay, let's see if this works. Okay, it's working. Our character stays idle, then walk and jump, and can't move in other direction while jumping. As a bonus, we can also add a dash, very similar to the jump, like this. Dash date. We are going to add a transition from idle and from walk to dash with start dash. And we also need to set up the dash speed. And when the dash is over, we go back to the walk. Let's copy this and add start dashing with an initial dash speed of 30. And also the dash update. When the speed is below 0, we will go back to the walk state, like this. And we have to decrease the speed every frame. more or less like the jump. And what we want to do is to keep moving toward the movement direction, but scaled by our dash speed. We also need to add a way to dash, and it will be by pressing the squeeze button here and here. Let's see if this is working. Okay, it's working. We can dash while moving, but we can't while jumping. And when we say idle, we can still dash. And that's all, folks. I hope you enjoyed this tutorial, and if you have any questions, I will be glad to answer them during the live session, and feel free to also contact me on Twitter or Discord. See you!
And as Elia already said, he is joining the Q&A. With that, Elia, welcome to the stream.
Hi all!
First of all,
Can you hear
thank
me?
you for...
It's fine.
Yes, I hear you perfectly. Wonderful. Thank you so much for your session.
Thank you.
I think everyone should have a very close look at that, and we're going to have a recording of it on YouTube later, and also upload the videos one by one later on, because it is really remarkable how the complexity of this kind of behavior that you're mapping with the dash and the jump and everything kind of like is nicely organized with all of this finite state machines.
That's really a bonus of using an FSM. It makes it easy to organize the code, and not only that, but to visualize what you want to do with a character or with a menu. You can easily see the steps, and it's easier to keep the control of that. You can't dash another way because you have to set the rules for that. It's really useful.
Exactly. Perfect. So we have a couple of questions here. Let's start with this one by Kebloy. Do you use state machines in Mr. Not? And any interesting problems FSM made a lot easier?
Well, I built the FSM that I've shown for Mr. Not. I've used it extensively, basically for everything. In the fast-forwarded session, I talked about how I've used it. For example, I've used it for the menu logic. So you know how to move from the main menu to the game, and then after the game you go to the result part, then back to the menu. And I've used it also to do sequence, like the intro of the game. You have this ring comes up, the ends appear, and the title is typed on the ceiling. That's an FSM underneath that shows the steps of this sequence. And also, as you can see here, for the enemies, like moving, exploding, stuff like that, it's really useful to don't lose your head over all of these changes. You can also use like a list of ifs if you want, but the things start to become very complex very easily, while with an FSM you keep it very organized.
That's a wonderful segue into the next question about other things that you could use instead of finite state machines. Spartamania 302 asks, what are the advantages of using FSM over classic behavior trees?
Well, I'm not an expert with behavior tree, but it's not like they are exclusive, because, for example, you can have the FSM for the character to organize the various things that the character can do, and you can use the behavior tree to choose when to do a transition. For example, you have the character that can jump and dash, and the behavior tree decide based on when it is in front, like I have an enemy, okay, I will dash, and in this case I will ask the FSM to dash, and the dash state will know how to hit the enemy and stuff. But if I have a cliff, the behavior tree will choose to jump and will ask the FSM to perform that action.
Perfect. We have NSTCG asking, can we make the player hit walls and climb stairs?
That's possible. You just need to implement the different things. The FSM let you split this kind of behavior, so you could add like jump and dash and climb whenever you are in front of a stair, for example, with a behavior tree, while the hit walls is more like a walk detection. It's not really something that you do with the FSM, but more like I'm moving, I have a floor in front of me, so I have to stop. What you can do is that if you were going like very fast and you hit the wall, then you can detect this particular case and switch perform a transition to a sort of bounce back state. So you run to the world and you do dong, and you can do anything while bouncing back, because you are in a state that does not let you perform anything until you have completed the animation.
Amazing. I mean, for hitting walls and climbing stairs, you also have this other project, right, with a character controller?
Yes, you can. Okay, yes. Yeah, I thought that climbing stair meant like a different kind of locomotion. But if you want to just have a simple locomotion system, as Jason have already said before, I'm making, it's not really completed, but I'm making a locomotion system that works with physics, and so let you climb stairs, hit walls, and slide, and all the stuff like that, like a character controller.
Yeah. Epic. Very, very cool. We have Yinch asking, do you have any plans to make a graphical editor for FSM?
Well, I don't think I have any plan in mind. Let me check. No, I don't have them. It
You
will
could
be
build it in
very,
Wonderland,
very
maybe.
cool, though. That will be very, very interesting, because like things like this, like FSM, behavior tree and stuff, works best when you can visualize them even more, like with a graph editor. But that's really an effort that will require a lot of work. So for now, it's not in my agenda.
Nice. I mean, maybe a visualization in like the EasyTune could work, like just something in VR, so you can visualize which state is currently active and these kind of things.
Well, maybe you
but-
could do something like that. Yes, maybe just the name and the arrows for the transition, just to visualize, but not to build that. Maybe that could work.
Amazing. And then in the intro, I had mentioned Sketchy, and I wasn't 100% sure if it was open source. Is that also released open source, like most of the projects that you do?
Yes. Sketchy can be found on GitHub, so you can look at the code. It's a bit outdated, so I don't think there was PP yet in there. But for the part where you can grab and how to transform the object, the code is there. So if you're curious, you can give a look.
You mentioned PP. What is that?
PP is a library that I built for the Wonderland engine. Some of this is just JavaScript, but most is working together with the Wonderland engine. So it's basically meant to be used with it. And it gives a lot of functionalities, for example, the FSM that I've used, and also gamepad, functionality to read the gamepad buttons and axes. So it's easier to work with that. And some other functionalities like an object extensions that makes working with object, like getting transform, making it look at something, etc., more easier, and it gives a more cohesive interface to that. I would not know how to work without that.
It saves a lot of development time, correct?
Yes, really a lot. As you have seen in the tutorial, I managed to do a lot of things with just like 30-40 line of code. So
yeah,
it's good.
In like 10 minutes roughly. So absolutely amazing.
I went very fast. Yeah.
For everyone interested, there is a PP default project which like bundles a couple of these utility libraries, and you can use it as a template basically to get your project started really, really quickly. Is there anything you're working on that you want to highlight,
right now?
Talk about? Yes.
The main thing that is on that I'm working on is the locomotion system, which I'm really proud of. I think it works pretty well, and I can't wait to share it in a complete state. And I'm also working right now. It's almost finished to virtual gamepad interface, so you will be able to play everything also on mobile. So
cool.
That will be shared really soon.
Amazing. I did not know about that. That's cool. Learned something new. Epic. With that, thank you so much for all the. You are one of the few people I can say thanks for the years you've been in the community, and
thank you.
Thank you for all the amazing work you did. again, like, I appreciate so much that you took the time and created this awesome session. I hope people look at it again and again, and then realize how amazing the work is that you did in the state machine library. With that, thank you so much, and see you soon.
Thank you.
Wonderful. That was our final session for today. And with that, I want to again express deepest gratitude for all the people from the community that presented today and put enormous effort into these sessions to share what they've been using in practice with Wonderland Engine. And it's often that you find like high-level tutorials on most of the things. We put out a lot of tutorials, but how things are being used in practice is always like a completely different topic. So this is absolutely fascinating. If you missed anything, no worries. We are recording everything. It's going to be on YouTube just once the stream ends. And we'll be releasing 3 separate videos with each of the sessions in the upcoming weeks, including the Q&A and everything. So you can have every session separately. So for that, please make sure to join our Discord server. It's on discord.wonderlandengine.com. And feel free to also ask further questions to Stephen, Daniel, and Elia if anything didn't get through in the Q&As. Make sure to subscribe on YouTube. Mo, who you might know from our YouTube videos, is working on entertaining but educating videos that are very fun to watch. And of course, the recording of this stream is going to be up there in a couple of minutes, and also the session recordings separately. Thanks everyone for joining us on stream. Thanks for your lovely comments, and thanks for all the questions, and thanks especially for the people doing and giving the sessions. I wish you all a wonderful rest of your day, evening, or morning, and see you in the next community workshops.